Good evening, everyone. My name is Kenneth Fahad and Mohammad Mriqdad, and I will be presenting on voice recognition systems, exploring technology applications and security. So today's agenda is first we will discuss introduce the topic to you and talk about how is it defined and some historical perspective. This will be followed by how voice recognition works. We will explain the basic processes that are involved in operations of a voice recognition system. Then we'll discuss some applications and try to understand some use cases and applications across different industries. And after that, we will talk about risks and mitigants, some potential threats, risks, and challenges that are faced in voice recognition systems, and their mitigants and best practices. And at the end, we will conclude this topic. So, first of all, starting with the introduction, we have according to the ISO standard, ISO IEC 238229 1999. Voice recognition is a technology that allows a computer or other device to recognize and interpret human speech, converting it into a machine readable format for processing and interaction. This definition highlights the core functionality of voice recognition technology, which is the conversion of spoken language into text that machines can understand and respond to. Let's delve into the historical timeline of voice recognition technology. In 1952, Bell Labs introduced the Audrey system. Audrey was capable of recognizing digits spoken by a single voice, marking one of the earliest attempts at voice recognition technology. In 1960s to 70s, IBM developed Shoebox, which was a machine capable of recognizing and responding to 16 words. Around the same time, DARPA initiated several speech recognition projects, leading to significant advancements in the field. In 1980s, we saw the introduction of hidden Markov models, which became a fundamental technique in speech recognition. HMMs allowed for better modeling of speech patterns. Then in 1990s, Dragon Naturally Speaking was released as the first continuous speech recognition system for consumers. This technology allowed users to dictate naturally, making voice recognition more accessible to the public. In the 2000s, this era brought significant advances with neural networks and deep learning, improving the accuracy and broadening the application of voice recognition technology. Additionally, Microsoft's Speech API was introduced, providing developers with tools to integrate voice recognition into applications. The 2010s saw the emergence of virtual assistants like Apple's Siri in 2011, Google Now in 2012, Amazon Alexa in 2014, and Google Assistant in 2016. These technologies brought voice recognition to mainstream consumer devices and thus revolutionizing how we interact with technology. And in the 2020s, we continue to see improvements in AI and deep learning, enhancing the capabilities and accuracy of voice recognition systems. These advancements lead to broader integration into a wide range of devices and industries. Now let's explore how the mechanics of voice recognition technology operates. We'll break down the process into fundamental components and explain each step in detail. The voice recognition process involves several key steps to convert spoken language into text. The first one is sound wave capture. The process starts with capturing sound waves through a microphone. These sound waves represent the speaker's voice. The captured sound waves are then digitized, converting the analog signal into a digital format that the computer can process. The second step is feature extraction. The digitized sound is analyzed to identify key features such as pitch, tone, and frequency. This step helps distinguish different phonemes, the smallest unit of sound that make up word. Techniques such as Fourier transforms and Mel frequency substral coefficients are commonly used for feature extraction. The third step is pattern recognition. The extracted features are compared against a database of known phonemes used using pattern recognition algorithms. This step involves matching the phonemes to form words. HMMs and neural networks are frequently employed for this purpose. The last step is language processing. The recognized words are processed to construct meaningful sentences. This involves understanding the context and grammatical structure of the spoken language. Natural language processing techniques are used to interpret and generate appropriate responses or actions based on the recognized speech. Moving on, let's understand the process deeply and cover some key components involved in voice recognition systems. The first one is the acoustic model. It represents the relationship between phonetic units and their acoustic signals. Created by analyzing a large dataset of spoken language and their corresponding text transcriptions. It uses statistical representations to model how different phonemes sound. The next key component is language model. It represents the probabilities of sequences of words. This helps in predicting the next word in a sequence, improving the accuracy of speech recognition. It also uses techniques like n-grams and more advanced models like long short-term memory networks to handle dependencies between words. The next key component is the decoding algorithm. Decoding algorithm combines the acoustic model and language model to find the best matching word sequence. The Viterbi algorithm is often used in HMM-based systems to find the most unique sequence of hidden states, given the observed data. Let's go through an example workflow to illustrate the process. The first step is capture. A user can say, turn on the lights. The microphone captures the sound and digitizes it into a waveform. The next step is feature extraction. The system will analyze the waveform and extract features like pitch and tone, identifying phonemes. The next step is pattern recognition. The system matches the phonemes to words, recognizing the phrase, turn on the lights. This step is followed by the step of language processing. NLP algorithms interpret the command, understanding the intent to control a smart home device. The system then sends a command to turn on the lights. This is all from me. Now, Mrig will continue from here. Thank you.
Thank you, Kenneth. Now let's discuss with application and use cases of voice recognition system. Voice recognition system utilize the unique characteristics of individuals' voice to identify or verify their identity. Those systems have various applications across different sectors. Different sectors are security and authentication, customer services, healthcare, automotive, and education. Security and authentication use cases banking and financial services. Voice biometric are used for secure access to banking services, enabling customers to authenticate transaction via voice. Integration in smart home devices for personalized response and secure access. Voice recognition for secure entry to restricted areas. Customer services like call center, automated customer services interactions, reducing the need for human operation. Virtual assistants, voice activated assistants like Siri, Alexa, and Google Assistant provide hands free operation and improve user experience. In healthcare, patient monitoring, voice based monitoring system for patient care and emergency alert. Transcription services, automatic transcription of medical records and notes. Automotive, in-car system, voice control navigation, entertainment, and communication system to enhance driver safety and convenience. Education sector, language learning, voice recognition technology in language learning apps for pronunciation and fluency improvement. Accessibility, assistive technology for individuals with disabilities, enabling voice activated command and controls. Use cases of voice recognition system, voice biometrics for authentication, use of voice recognition in bank and financial institution to verify customer identity. Voice control smart homes, integration of voice assistants for controlling home appliance, lights, and security system. Next is voice based transcription, automatic transcription services for healthcare professionals and journalists. Next one is voice activated automotive system, enhancing driver safety and comfort through voice activated control. Now let's discuss with cybersecurity risks and mitigation of voice recognition system. While voice recognition systems offer numerous benefits, they also introduce cybersecurity risks. Understanding the risks and implementing mitigation strategies is crucial for secure development. Cybersecurity risks are voice spoofing. Attackers can use recorded or synchronized voice samples to impersonate legitimate users. Replay attacks, playback of recorded voice command to gain unauthorized access. Next is phishing attacks, manipulating users into providing voice sample through fraudulent scheme. Data breaches, unauthorized access to stored voice data can lead to identify theft and privacy invasion. Noise and interference, environmental noise can disrupt voice recognition accuracy and lead to unauthorized access. Now let's discuss with some mitigation strategies. One is multi-factor authentication (MFA), combined voice recognition with other authentication methods like password biometrics for enhanced security. Liveness detection, implement algorithm to detect live voice input versus recorded sample. Encryption, encrypt voice data during transmission and storage to protect against unauthorized access. Continuous monitoring, monitoring system for unusual activity and implement real-time alert for potential security breaches. User education, educate user on the importance of voice security and best practices to avoid phishing attack. Regular update, keep voice recognition software and system updated with the latest security patches and improvement. In conclusion, voice recognition technology has involved significant and find application in various industries. While it offers numerous benefits, it also poses cybersecurity risks. Implementing robust security measures and best practice is essential to mitigate those risks. Continue advancement in AI and machine learning and broader adoption and improvement security mechanism are the way into the future for voice recognition system. Here are some references. Thank you.